Hi, this is the second of three videos about API 579 ASME FFS-1, the Fitness for Service Code, Part 16. If you have not watched Part 1, then I suggest you go back and check that one out too. Today we're going to talk about FRP damage evaluation. Have you ever considered how you can describe the damage that has occurred to your FRP equipment in engineering terms? This is a common question that engineers who work with equipment that's made of this amazing material ask themselves. I'm Jeff Clarkson, the Chief Technology Officer and founder of UTComp. Let's dive in. The full technical basis that provides a lot of the description of how to do this is in WRC 601, which is a bulletin put out by the Welding Research Council in the United States, and it's called Assessment of Existing Fiber Reinforced Polymer Equipment for Structural Damage. Use the 4th edition because it's got the complete information we need. The agenda for this presentation is part of a series of 3. The first one was for Fitness for Service Assessment, giving an overview of the part. This one is for FRP damage evaluation, which provides information or numbers, numerical values for engineering to the Fitness for Service Assessment. And the last one is for inspection, which is how do we get the data that we need to feed the evaluation. In overview, damage to FRP starts with polymer and the bond of polymer to reinforcement before it gets to damage to the reinforcement. The good news is that damage to polymers can be identified and quantified using non-destructive testing. There's acoustic emission testing, there's attenuation-based ultrasonic testing, and there's acousto-ultrasonic testing. The damage to polymers looks different than for metal alloys. The strength changes lead the way, and there may be no visible indicators. There may be, for example, if you're using ultrasonic testing, you may find no defects that you can pinpoint as related to damage. In evaluation, non-destructive testing data that was obtained in inspection is evaluated or processed to provide numerical values that are used for assessment. Measurements are required beyond visible observations. Remember, I noted a moment ago that many of the changes that occur to FRP, and in particular to the polymer, and especially to the glass, are completely invisible to visual inspection. So you can't see them, but we can detect them. So we have several different sources. We've got acoustic emission testing. I've talked a bit about that. Acousto-ultrasonic, which uses a type of ultrasound equipment and produces a quantity called a stress wave factor. Attenuation-based ultrasound, which determines the attenuation of the ultrasound as it passes through the material. And this becomes the attenuation created by the polymer. And of course, there's visual inspection, which tells us about the existence of open cracks or surface leaks. When we look at FRP and evaluate it compared to metal alloys, we come up with some differences. Evaluation of non-destructive testing from FRP is not the same as for metal alloys. Different methods and skills are normally required than provided in standard certifications. These certifications, because FRP evaluation has not been really commonplace, they haven't been taught. They haven't been trained into inspectors yet. Specialized training is required today. We have to provide specialized training for both the inspection side, but also especially for the evaluation side. All non-destructive evaluation produces results that includes the full thickness of FRP. We can't separate off the corrosion barrier in the field with the inspection information. The corrosion barrier, bonds at the test, structural elements, and any reinforcements or additions are included in all of that information. Ultrasonic testing readings may actually identify different zones within the FRP, such as corrosion barrier damage, or we also have methods to determine the depth of cracks. The charts I'm showing up here right now are examples of the charts we use to determine polymer damage status. Remember this from the first video, the PDS, to determine PDS from the results of acousto-ultrasonic, which is AU, and attenuation-based ultrasound, which is UAX. These examples or these methods both require one or two or more calibration samples, which can make them a little bit challenging. With acousto-ultrasonic, it is possible to do this with a single calibration sample. You can't use a single sample for attenuation-based ultrasound. Explanations for that are actually included in the Welding Research Council Bulletin. There are some features about non-destructive evaluation that I'd like to talk to you about. First is, there are no changes required to acoustic emission testing certification. So if you're certified for acoustic emission testing and you apply that to the FRP equipment, there's no changes to your certification to get the result. For acousto-ultrasonic and attenuation-based ultrasound, well, there actually isn't any certification available from groups like the American Society for Non-Destructive Testing that provide you with all that you need. But you can get employer certification according to SNT TC1A that will allow you to be able to evaluate that or teach you how to evaluate that material. Many of the techniques and methods that are required for acousto-ultrasonics and attenuation-based ultrasonics are not covered in any of the general ultrasonic testing or acoustic emission testing certifications. Part 16, Annex D and Annex E actually provide procedures for evaluation if you go down that path. And the reason is we didn't want this to be a barrier. After we've done the evaluation, what data has to go for assessment? Well, we either need to provide the acoustic emission testing result, which is straightforward and given by the procedures, and we provide thickness. We need PDS from acousto-ultrasonics or attenuation-based ultrasound, and we still need visual observations because we have to know if there's cracks or leaks in the equipment. Clearly, if equipment is leaking, it's not fit for service. Summarizing, this is actually fairly straightforward. Evaluation uses non-destructive testing data to provide engineering values that are used for assessment. Before I close out, I want to talk about this t-shirt. This is kind of the crossover of inspection and evaluation. FindX is exactly what we can do from inspection. And see, the inspector found it right here. The problem is the guy who does the evaluation has to figure out what it is. And I'll leave it to you to know what that answer is, and I'm sure that you can figure it out. Thanks for listening. Don't hesitate to reach out. Give us a call. You can find us at utcomp.com. We look forward to hearing from you. Have a safe day.